Okay. Hello everyone, and welcome to Statistics 479. This is the topics course on multivariate statistics. I'm your lecturer, Garvesh Raskuti. So welcome back. I hope you all had a good summer. I know it's been a very different and potentially difficult period for people. So I hope everyone is staying safe and healthy. And yeah, look forward to the semester. Although the whole teaching and learning process is potentially a little bit different for everyone. So today, I'll begin with lecture one. And generally, this is going to be a pretty kind of light lecture. I'll mainly focus on kind of the course format and the logistics. Talk a little bit about some expectations for the course and some tips for doing well. And then I'll motivate the course a bit by going into why we're covering multivariate, why multivariate statistics are is a potentially interesting topic, and I'll present a couple of examples which hopefully illustrate that point. And then I'll finish in the last sort of 5 or 10 minutes or so by talking about just the general setup or statistical framework that we'll be looking at throughout the course, and I'll provide a simple example just to illustrate how that framework's going to be used. So to begin with kind of the course format and logistics, so this is an online asynchronous course. So that means that video lecture content will be provided each week. So and the way I'll be doing it is there'll be 2 video lectures per week made available at the beginning of each week. So typically, if I was teaching a course like this in a classroom setting, there'd be 2 75-minute lectures. So I'm going to try to keep it a little bit similar, apart from the fact that we have apart from the fact that the lectures are asynchronous and online, and just have 2 lectures that are about 60 minutes roughly. And they'll be available at the beginning of each week. So it's your responsibility to watch and learn from those video lectures. Then the main for sort of face-to-face contact that we're going to have is via office hours, both for the TA and for myself. So my office hours are Thursday 1:30 to 3 p.m. And that'll be done via BB Collaborate or Zoom. I'll figure out the best technology. In general, I'm only going to be available if appointments are set, just to make sure that that there's going to be people there. So even if you set an appointment, maybe 10 or 20 minutes before the office hour, that's fine. Just email me to let me know that you would like to make an appointment. And then the TA office hour, so the TA is Yongfeng Wu, who's very good. His office hour is going to be Wednesday 3 to 4 p.m. and that's also going to be done remotely. So now I'll move on to kind of assessment and grading. So there'll be 5 assignments worth 10% each, so it's a total of 50% of assignments. And then there'll be 1 class project at the end of semester that'll be worth 50%. So now just to talk a little bit about the homework assignments. So they'll be due approximately every 2 to 3 weeks. The first assignment is due on Thursday, September 24th by 5 p.m. And by the time you listen to this, I should have posted that first homework, although I cover material from the first couple of weeks. This is an online course, and all homework assignments should be submitted via Canvas. So that's going to be the medium that we're going to be using to communicate. So now I'll move on to talking about very briefly about the course project. I'll say a lot more about that later on in the semester. So this will be done in the second half of semester, and Okay, and so just to give you a heads up, this will involve a combination of finding a data set or a scientific problem yourself and then applying methods learned in this course. You don't need to concern yourself too much with it now. I'll talk a lot more about it, around, week 6, 7, 8. And that's when we can kind of start to get going. I just kind of wanted to flag it at the beginning. So the project will be due at the end of the semester, and I'll start to talk about it in more detail about 5, 6 weeks before the project is due. When you're in a position to use to apply some of the methods that we learn in class. Okay, so the next thing I'll talk a bit about is the prerequisites for the course. So this is a topics or seminar course. So like the prerequisites are not, extremely strict, but I'm gonna give you a sense of kind of what I kind of expect from you throughout the course. And I guess if you don't meet those prerequisites, I'm guessing that you'll find elements of the course, and particularly the homework problems and the project, quite challenging. So I'm sort of putting it out there now so that you don't feel surprised as we go through the semester. Key prerequisite is mathematical statistics, which is it's Stat 310 here, or some equivalent of that. We're going to be using a lot of terms from Stat 310, like estimators and other terminology like that, and so you'll certainly like having that as a prerequisite's pretty important, or some course that's basically equivalent to that. We'll see that elements of the course are quite mathematically heavy, and so certainly Stat 310 will be important. As I mentioned, there's going to be elements of the course that are quite mathematically heavy, and in particular, sort of two concepts in mathematics that are going to be very, very well covered are linear algebra and multivariate calculus. Those should be prerequisites for Stat 310 or equivalent, so hopefully you've seen that, but you will need to be really, really comfortable with the techniques and operations from there. I mean, this is a course on multivariate statistics, so you can imagine that you're doing maths with lots and lots of variables, so linear algebra, like matrix, vector operations are going to come up a lot, and multivariate calculus, differentiation and integration over multiple variables is going to come up a lot and a lot. So those are very, very strong prerequisites that, I'm sort of I'm expecting you to have taken those courses, and I'm going to be really very I'll be expecting you to be very, very comfortable with the operations from that course. And just to follow on from that point, general mathematical sophistications. I mean, it's a pretty vague thing to say, but as I mentioned, there'll be aspects of the course that are mathematically quite heavy. And I'm expecting you to, to be mathematically sophisticated in the sense that, if I go through a proof or, use a technique like proof by induction or something, that's something that you've kind of at least, that you're somewhat familiar with. And so it's not like if like that, you're not surprised if you see sort of like some mathematical steps like that throughout the course. Okay, the final thing and the final element of this course is that there will also be a reasonable focus on algorithms and in particular computing and programming in the course. And so it's not a prerequisite that you have done some programming, but hopefully in Stat 310 or some of the courses you've at least done some little things in R. But you certainly will have to be able to implement some simple algorithms in this course. So, like the homework problems and the final project will involve you implementing some some reasonably simple algorithms. So if you have done some sort of programming, that will be extremely useful. And if you haven't, then there's going to be a bit of a learning curve for you in terms of picking up certain concepts. So later on in the course, I will actually put up some sort of introduction to R slides. So just to give you a basic introduction to R. So if you haven't seen any programming, you can at least start with that. But I'm sort of warning you already that as I mentioned, the course will be mathematically quite heavy, but then there'll also be the expectation that you can implement some simple algorithms on computers. And so that's another skill that's going to be required in the course. Okay, so the final thing, the next thing I'll talk about is the, how we're going to communicate with each other, and pretty much all the communication that we do in this course is going to go through the course website. So that's the Canvas website for this course, So in particular, all video lectures will be made available on the course website, possibly through YouTube links, because it seems that YouTube, like creating a YouTube channel, may be the most efficient way to actually set this up. But that'll be linked to the Canvas website. All homework assignments and notes are also made available on the website. So I've already posted some notes and your first homework assignment on the course website, and so that's where you'll kind of see that material. And also all announcements we made on the Canvas website. And so, the take-home message is it's your responsibility to check that website frequently. You have to watch the 2 video lectures each week, and you have to check for the homework assignments and any announcements about deadlines or changes to assignments will be made on that. So make sure you're checking that frequently and not checking the website. Certainly not an excuse. And if anything at all is unclear, with any of the communication on the website, please feel free to email me or come to my office hours to make sure that things are clarified. So that's your responsibility to make sure that you're on top of everything of the content that I make available and what you need to know for this course. Okay, so now I'm going to just give you a few tips on kind of navigating online material. Okay, so first of all, I mean, when you signed up for this course, you potentially were not thinking that this was going to be an online course, and for some of you, this taking an online course may be a new experience, and it's potentially unexpected and maybe even undesirable. And like I'm in the same boat as you guys. Like all the courses I've taught before have all been in classroom courses, and so I'm learning on the go as much as you guys are about teaching an online course. So certainly it's a new experience for me. And so in terms of tips for the online aspect of the course and generally doing well, I'll kind of there's both pros and cons, and I think having the right attitude and trying to still make the most of this course will you might actually find that there are things you actually prefer about the doing the course online compared to the classrooms. And there's certainly things you can't replace, and that sort of goes without saying. But I think that potentially you might learn that there are aspects of online courses that you really like. Okay, so the pros and cons are sort of reasonably obvious. So one of the real pros of online courses is that online content is made available for consumption at your convenience. So I'm going to post these video lectures at the beginning of each week. And so you can kind of consume these at your own convenience. You can stop if there's something you don't quite get and think about it. Normally in an in-classroom setting, I would just be talking and writing on the board and potentially stopping for breaks. And then that there's no sort of recording of that, and you sort of have to maybe write it down or just try to recollect what was being said. Whereas here we're going to have video lectures available each week, which you can kind of play at your own pace and consume them at your own pace. So this is kind of a pro potentially, but this is also potentially a con because there's online content available in an in-classroom setting. There was at least a time which sort of forced you to come to class and to engage and take notes. In this case, you really need self-discipline to ensure you take in the materials. So if you like, you don't have a set time, so you can do it anytime you'd like, but that means you have to force yourself to do it at a specific time. And the other thing, which is a big con and something you'll need to think about, and I'll try to help you with that, is you need to find ways to overcome lack of face-to-face contact. And this is something, as I mentioned, that I'm also dealing with as a lecturer. I like lecturing and seeing people and having interactions, which is something that we don't exactly have in this setting, and that's where the office hours are going to be extremely useful and something that you'll need to make the most of. And so the general tip I'll have is to set your routine and stick to it. So say that each week I'm going to watch these video lectures at this time and take them in, and then potentially if you have questions, then you can attend the office hours of either myself or the TA Yongfeng. Okay. So the one and big sort of most general tip I would give for doing well in this course is that consume the lecture material actively. And this is a tip that I would give for whether it's an in-person class or it's a in-classroom class or an online class. It's very easy to kind of what I'd say passively take notes, which is where you're kind of sitting there watching the video lecture or sitting in a classroom, and you're kind of just sort of listening to what the lecturer is saying, and you feel like you're getting what's going on. But this is not really going to be very useful in terms of you taking in the material and being able to do the homework assignments or the course project, because to consume lecture material actively means that you kind of need to be an active participant while I'm giving lecture notes. So what that means is, while I'm giving lecture notes, just sort of take notes yourself. And that doesn't mean copying down everything that's said or written here. It means just, thinking through, jotting down some notes and questions that you have along the way. Do all the examples that I do in class. So we're going to have a couple of examples today. And so do those examples yourself and try to, think through those examples carefully. And then try to recreate the lecture content. So this is really, I would say, the ultimate level that you've understood the lecture. If you can kind of recreate a lot of the contents of the lecture, and you'll be surprised how hard this is to do. So when you watch a lecture, think in an hour or two's time, could I sort of recreate a lot of the content that was taught there? That's a good test to see if you've really kind of understood and taken in the material. Okay, so this is a tip that I would give for an in-classroom class, but it's probably even more relevant for an online class, and that's to really make use of the office hours. And that's either my office hours or the TA Yong Feng's office hours. So, and what I mean by that is you really need to take advantage of this by bringing really pointed questions and thoughts. So as I'm mentioning, if you consume the lecture material actively, you'll kind of write down various notes and thoughts that you have, and then there might be some things that you don't quite understand or that you want clarified. And so bringing those questions or thoughts to office hours after consuming the lecture content is really important. So I and the TA will not be very sympathetic if you come to the lecture saying, come to the office hours saying, I haven't watched the lectures, could you please explain to me everything in the lectures? That's sort of not what the office hours are really intended for. And as I mentioned, make sure you make an appointment beforehand, because that's also a sign that I know that you've really thought about it, because you're putting in the time to make sure that you really sort of have thought about the questions that you'd like to ask me. Okay, so that sort of finishes the discussion on the logistics, the expectations, and some general tips for the course. And so if there's anything that is unclear to you, please feel free to email myself or the TA. I want to make sure that that everyone is clear on what's expected, and what that there's no misunderstandings about what needs to be done in the course. So now we move on to the next part of the course, which is really before teaching any course, I like to motivate why anyone would want to study this. So here we're looking at the question of the motivation behind the course, and sort of why are we interested in multivariate statistics, and in particular I'll talk about high dimensional statistics too. So the first key point is that Okay, so the first sort of reason why multivariate statistics are interesting, and hopefully this is something that's not too great a surprise to all of you, is that most, if not almost all real applications involve multivariate data. Um, and so, you know, I've just given a couple of examples here. So in finance, there's potentially many relevant features if you know, want to predict like stock price or anything else. Like it might be, you know, what's the economy in the US doing? You know, what are interest rates for banks? There's potentially, you know, hundreds to thousands of different features that might influence what the stock price is doing. In genetics, you're typically interested in modeling the effects of thousands, sometimes even millions of, or tens of thousands or hundreds of thousands of genes on some particular output of interest. And so you have, you know, potentially hundreds to thousands of different variables. And this is where kind of the notion of high dimensionality comes in, which I'll talk about in a little more detail throughout the course, is that here the number high dimensionality really kind of it's a pretty vague term that refers to the scenario where the number of variables is extremely large, which presents some computational and statistical challenges, and these often occur in finance and genetics. Okay, and so the second reason, and I guess the reason why you'd want to take a course on it is that, yeah, so there are many applications that involve multivariate data, but, you know, why can't you just kind of like, you know, why is it difficult to just not apply some of the principles that you know for, say, you've probably learned about like simple linear regression or other like correlations or other kind of ways of dealing with one or two variables? Why can't you apply this to multivariate data? And as we'll see, this present kind of unexpected challenges or complexities that need to be accounted for. And we'll cover a couple of examples that hopefully illustrate this point. And the thing that we really want to take out of the course above and beyond anything else is to give you some ideas of the challenges that arise with multivariate data, and also some potential tools on how to deal with that. So this is really you know, the main focus on this course. So let's like try to, you know, everything I've been saying is very vague and airy fairy. So let's begin with a couple of examples. Okay, so what we're gonna do is look at a scenario here where we're investigating the question of whether there's gender bias in admission. And so this is a 1974 paper about admission to or at Berkeley. In you know, from, I believe the data is from 1974. And I'll sort of begin by saying that I'm not presenting a perspective on this. I'm just presenting results from a study that was done. And the point to take away from this is really the effect of multiple variables, which I'll get to shortly. So first, let's look at the raw data. Okay, so the raw data consists of two variables, basically gender and admission, and we want to see if there is is there a bias towards, are more men or women being admitted to Berkeley. And so if we look at the raw data that's presented in this paper. Okay, so the raw data says that in 1974 that 8,444 men applied and 4,321 applied. And then of the men, 44% of those men were admitted and 56% were not admitted. And for the women, 35% were admitted and 65% were not admitted. So this, the suggestion would be that so that men are more likely to be admitted because the admission rate for men is higher than women. Now what we're going to do is we're going to add a third variable. So this course is about multivariate statistics, and so really I would say that you've potentially seen lots of examples with two variables. So in 310 and other scenarios with simple linear regression. So now we're the the simplest example of multivariate statistics beyond two variables is three variables. So let's look at that. So we're going to introduce a third variable, which is the department. And what I mean by here is just the department that people apply to. So now let's look at exactly the same data, but in a different way. Okay. And I should also make myself clear that I'm assuming here a binary notion of gender, which I know is potentially a bit outdated, and this is from 1974. And once again, I'm not illustrating a perspective on I'm not expressing a perspective on this. It's just we're trying to determine the effect of this third variable of department on this question of gender bias. So now we're going to say that there's 6 different departments. We'll label them A, B, C, D, E, and F. And I'm going to talk about the breakdown of how the men and the women and how many applied and their admission rates for each of these departments. Okay, so now if you break it down by department, you can see that in general, if we look purely at the data, there's not a clear trend of gender bias like there was if we viewed the data set in the raw data. Once again, I'm not sort of saying that means that there isn't any gender bias. I'm just purely talking about like what the data tells us. And the main conclusion out of this is actually that okay, and women tend, like based purely on this data again, that women tend to apply to departments where the admission rates tend to be lower, so they're more challenging to get into. So more women tend to apply to these, and that's why the overall admission rate looks lower for women than it does for men. And once again, I mean, there are other humanistic factors that I'm not discussing here at all. This is purely just the main conclusion to take out of this is that so if we ignore z, it seems there's a dependence between x and y in the sense that if you if you ignore the department, it seems that if you're a male, you're more likely to get accepted than if you're a female. And on the other hand, if and if we include or model z, then we could say that either there's no dependence between x and y, or that the trend is reversed. And this example is a classic example for illustrating what's known as Simpson's paradox. And this occurs because you have 3 variables rather than 2. So this is kind of so this dependence between x, y, and z clearly influences our conclusion. Let's do a second example. So we're going to illustrate what happens when you kind of go from 2 to 3 variables in another sort of nice, I think, simple and cute example here. Here you flip a fair coin twice. So the fair coin either has a head or a tail as its outcome. And if the outcome is the same, so it's either head or tail, you ring a bell. Otherwise, you don't. And so now we have 3 variables again. X is the outcome of the first flip. Y is the outcome of the second flip. And D is that you ring the bell. Okay, and so the question is, are X and Z dependent or independent? So the outcome of the first flip, does that influence whether you ring the bell or not? So I'm going to claim that depending on how we phrase how we phrase that question, you potentially could get two different answers. Okay, so if we look at the event that the probability that X, you roll ahead and that Z equals 1, that is just corresponds to the probability of flipping ahead twice, which is a quarter, because the only way that you would ring a bell and the first coin flip would be head would be if the second coin flip was also head. And the only way that can happen is if they're both heads. Now let's look at the probability that X's heads is obviously a half, and the probability that you ring the bell is also a half, because there's 2 outcomes, because there's 2 possible events, heads, or tails. And so what that means is that we have that so what we have is we have the equation that satisfies independence. So we'd say, so therefore we'd say that X and Z is independent. The next question is, are X and Z independent if you know that Y is ahead? So let's do this calculation. So given that we know that the second flip was ahead, we're looking at the probability that X equals head and Z equals 1, given that Y equals head. So we've already assumed that Y is ahead, and so this just corresponds exactly to the probability that X is ahead, and so this is just equal to 1/2. Then on the other hand, if we look at the probability that X is ahead given that Y is ahead is 1/2, because the coin flips are independent. And then the probability that Z equals 1 given that Y is ahead is also 1/2, because if if you know that the second is ahead, the only way that Z is 1, that you ring the bell, is if the first is also ahead. This is a half. So what we see here is that okay, and so therefore we get that they're in fact not independent. And so what we have is this kind of conclusion that we're going to see sort of quite often, and something you really need to be careful of when you're dealing with multivariate data, is that so X and Z are marginally independent. So marginally independent here means that you ignore completely what happens to Y. But if you condition on Y, or if you know what happened to, like, with Y with the second flip, then they are actually conditionally dependent. So this is something that's like, one of the key things to take away from this course, and one thing that you'll hopefully learn throughout the course, is the difference between marginal and conditional dependence. And they're actually very, very different things. And this is something that people easily confuse. And so what we're going to see is that when we go from 2 to 3 variables, we can already see how sort of this can be a little bit mind-bending already, because you have complexities in going from 2 to 3 variables with, how do these different dependencies influence each other? And this is going to be a big talking point throughout this course. And, as we saw with the first example on gender bias, that potentially if there's a hidden variable like department, how that potentially influences your conclusion. So these are all issues that arise when you have multiple variables. Okay, and so, I've talked about what can happen if you have 2 or 3, if you go from 2 to 3 variables, but now imagine going to hundreds or thousands or even millions of variables, and you can see that things can get very complicated potentially very, very quickly. And so that's hopefully a motivation for why there's some value in studying a course like this, to give you some principles to deal with these complex dependencies. Okay, so now we'll move on to the general setup and notation that we're going to kind of use throughout the course. And there's basically, in a nutshell, going to be 2 settings that some of you who've seen machine learning or statistics before may be familiar with. There's an supervised and unsupervised setting. So here the data that we have, or the data that we observe, will be given by this notation. In the supervised setting, we have okay. So let me just explain this notation a little bit. P here is the number of variables. N here is the number of samples. So all I'm doing here is introducing some notation that we're going to use throughout the course. And here we have that okay, and so what makes this a supervised setting is that we have this response y. So I'm using this subscript notation to refer to the variable index, and then this superscript bracket like notation to refer to the sample index. But what we have in the supervised setting is the is the y variable. In the unsupervised setting, it's pretty similar, but we don't see a y. So this is why it's called unsupervised, because there's no response that kind of gives us some idea about what's going on between these variables. So we're going to see some scenarios where we have supervised data. So for example, you might imagine that these x's are just gene expressions for different genes, and the y is some response, like whether someone has cancer or a particular disease, and that's going to be a supervised setting because we observe a response. Another setting you might have is an unsupervised setting where all you might do is observe, say, the stock price for p different variables, say, and you want to see how, for p different companies, and you want to see how those companies interact with each other. There's no real response to those variables here, so we have here that there's no response y here. There's no response y here. And so we're going to have both of these settings. And as I mentioned, the subscript index refers to the variable index, and the superscript bracket index refers to the sample index. Okay. Okay, so that'll be all that we'll focus on for today. So we'll kind of get into the core material in the next lecture. And so hopefully today was a pretty gentle introduction, and we'll kind of start with some of the key material. In particular, we'll focus on multivariate linear regression in the next lecture. Okay, thanks for your time, and let me know if you have any questions.